Bismillahirrahmanirrahim. Students, today we are talking about a linear equation, and chapter number 2 is all about the implications of linear equation. As you know, we started this subject from the definition of mathematics, and then we move towards what are the types of equations, what are the functions of equation, different functions, what are the types of functions, and we started our discussion from first degree equation or linear equation. And you know what is first degree equation? A linear equation where the power of variable is 1 is called first degree equation. Then we have discussed how to solve the first degree equation. We simply put the variable one side constant, other side, then we can simplify and we will be getting an answer, and that answer is called root of equation. If that answer satisfies the equation, it means while putting the value of that variable into equation, if both sides get equal to each other, then we can say that equation is satisfied. Then we can say equation is satisfied, and that is called the real root of equation. So exercise number 2.1 is related to linear equation. If we look at question number 1 to question number 18, simply we have to differentiate. Either the question or statement is linear or not linear. When you will be able to make the decision either the statement is linear or not linear, if you have the understanding of the first degree equation or linear equation, its definition and so on. So you are very clear that what is a linear equation. Linear equation where the power variable is 1 is called linear equation, and all the variables are separately distributed. Okay, then we can name it as a linear equation, and all variables are having power 1 is called linear equation. If we look at question number 1, minus 3y is equal to 0. Minus 3y is equal to 0. So here the variable is y. Here the variable is y, and the power of variable is 1. So we can name it linear equation. Same as question number 2. 2 under root into x. 2 under root into x plus 6y is equal to minus 25. Under root is on coefficient. Only on coefficient. If it's on variable, then we can say it's not linear. Okay, because we are required power 1 on variable, then we can name it linear equation. So if we have we look at question number 3, minus 5x plus 24y is equal to 200. Here we have two variables, x and y, and both are independently distributed, separately distributed, and both are having power 1. So that expression is also a linear expression. Look at question number 5. What is question number 5? 2x minus 3xy. Here two variables are going to multiply plus 5y. So we can name it, it's not linear. As we stated, all the variables are separately distributed, and that is a non-linear equation. Question number 9, m by 2 plus 2m minus 3n whole divided by 5 is equal to 0. Variable is here we have two variables. There are two variables, m and n, and both variables are having power 1. We are not concerned. Variables are going to divide by anything, any constant. If one variable is divided by another variable, then we can't name it as a linear equation. Here variables are separately distributed, m and n, but they are going to be divided by any constant. Then we can name it that is a linear function, a linear equation. There are 18 questions, and you can make decision by yourself that either it's linear or non-linear. If question number 17, what is question number 17?
Under root x square plus 2xy plus y square.
X square plus
2xy
2xy
plus y square
y square is whole under root is equal to 25. So keep in mind the definition where the power of variable is 1 is called linear equation. So in this case, by look, the power is 2, but we should be very careful that we know about the formula a square a plus b square, a plus b square, a plus b whole square is equal to a square plus 2ab plus b square plus b square. So if we simplify it, here is x and y whole square is equal to x square plus 2xy plus b square. So can we write here x plus y whole square whole under root is equal to 25 is equal to 25. So we can square and under roots are cancelled. Square and under roots are cancelled. What's left? X plus y is equal to 25. Now you can make decision based on the power of variables. So here the power, we have two variables x and y, and both are having power 1. Both are having power 1. So we decide, we can conclude it's a linear equation. It's a linear equation. Clear, students?
Yes, sir.
So these are question number 1 to 18 are just related to differentiate either case is linear or non-linear. Now we are having practical nature questions which are widely used in our daily life or in corporate sector, and we can utilize a mathematical equation or linear function, how linear function work in our daily life problem. So question number 19 to question number I think 30, they are important question, but the most important thing is we have to we have to properly understand what is given. Very simple. What is given, what is required. What is given, what is required, and what is the procedure to simplify the answer. Okay?
Yes.
These questions are also related to linear equation. These questions are also related to linear equation. And question number 19, if we look at question number 19, what is question number 19? Consider the equation 8x is equal to 120. Consider 8x is equal to 120 as a
two variable
equation. Question number 19. 8x is equal to 120 as a
two
variable equation. Two variables equation. That is important to understand. But we have only one variable. How we can rewrite, how we can draw the function as a two variable equation? Can we write it 8x plus 0y is equal to 120. 0y is equal to 120. So now is it two variable equation or not?
Yes,
because we place the second variable, but the coefficient of any variable is 0 will be equal to 0. The overall expression of the equation is not changed. So we can name it as a two variable equation. Clear, students?
Yes.
So in this case, they stated that two variable equation having the form equation 2.1 define a, b and c. Variable 1 coefficient is denoted by a, variable 2 coefficient is denoted by b, and constant is represented by c. So what is a? Part A, what is a? That is coefficient of first variable. Part B, C, B is the coefficient of second variable, and C is constant. In this case, in part A, we have to differentiate, we have to determine what is A, B and C. So what is part B?
What pair of values satisfies the equation when y is equal to 10?
What pair of values can satisfy the equation when y is equal to 10? So B part, if y is equal to 10, then we have to find the pair of values. We have to find the what pair of values can satisfy the equation if y is equal to 10. So we can simplify 8x plus 0 into 10 is equal to 120 is equal to 120. So first degree equation variable is already one side, constant is already other side. Then we can simplify x is equal to 120 by 8. So 0 multiplied by 10, answer is 0. So x is equal to 15. So the pair is 15 and 10 because the value of y is given. So if the value of y is 5, value of y is minus 100, minus 10, minus 20, minus 30, does it make any change in the equation?
No, sir.
Any value of y will not bring change in the equation because its coefficient is 0. 0 multiplied by anything will be equal to 0. Okay, students?
Yes, sir.
So any value of y can be there, but x must be equal to 15. Rather than 15, nothing will be satisfying the equation, and any value of y can be there. Clear, students?
Yes, sir.
In part B, we have to determine what pair can satisfy the equation if y is equal to 10. If y is equal to 10, any value of y can satisfy the equation. Okay?
Yes.
But x must be equal to 10. What is part C?
What pair of values satisfies the equation when x is equal to 20?
Part C, when x is equal to 20. What pair can be what pair of value can satisfy the equation? As is stated,
Yes.
x must be equal to
15.
X must be equal to
15.
So here the value of x is
20.
So we can say rather than 15, none of the pair will satisfy the equation because at any value with any value of y, with x must be equal to 15 with any value of y can satisfy the equation. But in this case x is equal to 20. X is equal to 20. So we can simplify, we can denote x is equal to 20 can't satisfy the equation because x must be equal to 15 with any value of y will be only unique solution set that can satisfy the equation. Clear, students?
Yes.
What is part D?
Verbalize the somewhat unique nature of the solution set for this equation.
Yes, verbalize the somewhat unique solution set. Somewhat unique solution set. What can be somewhat unique solution set? In this case, x must be 15 with any value of y can be a unique solution set. So in part B, what we have to define? So we can say x must be equal to 15 with any value of y can be a unique solution set which can satisfy the equation. What we can write?
X
must be
15.
equal to 15
with any value of y.
With any value of y
can be a unique pair.
Can satisfy. Can be a
unique pair.
Unique pair or solution.
Yes. Which will satisfy the equation.
Okay. Which will
Satisfy.
satisfy
The equation.
the equation. Okay, students?
Yes, sir.
In this case, that is very simple question, but we have to use the logic. We are having only one variable. If they state 8x is equal to 120 as a 5 variable equation, as a 5 variable equation, 0y plus 0z,
Yes, sir.
that will be 3. So here we can write 0w,
Yes.
then 0,
U.
whatever the expression is, that will be the 5 variable equation. Okay?
Yes, sir.
So you can simplify and verbalize the solution sets. Same as question number 20, 21 and so on. Question number 23, question number 19, 20, 21, 22 and 23 are the same questions. And you are supposed to solve these questions by yourself. Now we move forward to question number 24. More practical question. What is question number 24?
Product mix. A company manufactures two products A and B. Each unit of A requires 3 labor hours and each unit of B requires 5 labor hours. Daily manufacturing capacity is 150 labor hours.
Okay, then
If X units of product A and Y units of product B are manufactured each day and all labor hours are to be used, determine the linear equation that requires the use of 150 labor hours per day.
okay, there is a product mix. It means if you focus on the word that is a mix. Whenever we talk about mix, it means that is a combination of more than one product. But in this case, there are two products. One is product A, second one is
Product B.
B. One is product A, second one is product B. And product A is denoted by X, product B is denoted by Y. Clear, students?
Yes.
And there is total capacity. There are total daily manufacturing capacity is 150 labor hours. Daily manufacturing capacity is 150 labor hours. So, product A, to manufacture a unit of product A, 3 labor hours are required. 3 labor hours are required. To produce a unit of product B, then 5 labor hours are required. How many are total labor hours? There are 150 total labor hours. So in this case, they have stated the firm is having total 150 labor hours, and there are two products. One is product A. To make a unit of product A, there are 3 labor hours, and to produce a unit of product B, they are required 5 labor hours. But what we have to determine in this case, we have to determine the linear function. In this case, we have to determine the linear function which is given in the question. What we have to do? Determine the linear equation that requires the use of labor hours per day. Okay, part A. We are very clear. X are the number of product A. Y is product B. Let X is
Product A.
Question number 24.
Yes.
Let X is product A. Let X is product A. Y is
Product B.
product B. Y is
Product B.
product B. So, total labor hours are
150.
Hours are
150.
150. Total labor hours are 150. In part A, we have to determine the linear function. To make a unit of product A, 3 hours are required. To make a unit of product B, 5 labor hours are required. So, 3x plus 5y is equal to 150. Why we place 3 and 5 here? Because x represents product A.
Yes.
How many labor hours? 3. So the coefficient of x will be 3. And y represents product B. So how many labor hours are required to produce a unit of product B? Those are 5 labor hours. And total capacity is 150. And in this case, we have to simply determine the linear function. So the linear function is 3x plus 5y is equal to 150. That is part A. What is part B?
How many units of A can be made each day if 25 units of B are manufactured each day?
Okay. How many units of product A can be made? It means here we are required to determine the value of X.
Yes, sir.
And what is value of Y? If
25.
Y is equal to
5.
5, then what we need to determine?
X.
X is
1.
we have to find. So 3x plus 5, what's the value of Y?
25.
The value of Y is 25 is equal to 150. 25 is equal to 150. Here we can simplify 3x plus 125 is equal to 150. So 3x is equal to 150 minus
125.
first degree equation.
Yes.
Shift the variable.
One side.
One side constant.
Other side.
Side minus 125. So 3x is equal to 25.
Yes.
So x is equal to 8
Double 3.
double 3 units of product A can be produced. If one can produce 25 units of product B, then one can produce 8.3 units of product A by utilizing 150 hours in a day. Okay?
Yes.
What is part C?
How many units of A can be made each week if 12 units of B are manufactured each day? Assume a 5-day work week.
Okay, here first we have to rewrite the equation as a weekly equation. It's daily equation,
Yes, sir.
Yes.
and first we have to convert the equation into weekly equation. How many days are in the week? Working
Five.
days are 5 working days. Okay,
Yes.
first we can simply multiply this equation with 5 because we are going to convert as a weekly equation. So what is weekly equation? Part C. Weekly equation. We have to there are 5 working days. So 5 into
3.
3x. So 5 multiplied with 3 is 15x
Yes.
plus 5 multiplied with 5 is
125.
25. So 150 multiplied 5 is
750.
750 hours. So in question they have given how many units of product B are there?
Yes, sir.
How many units? 12 units. How many units?
12
12 units in a day. If they produce 12 units of product B in a day, how many number of units of product A can be produced? So if Y is equal to 12, then we can find the value of X. We can find the value of X. 15x plus 25 into 12, 750. So 15x is equal to what's here?
300.
Plus 300, 750. So 15x is equal to 750 minus 300. So x is equal to 450
Yes.
by 15. What's answer?
30.
30 is the value of x. Then they can produce 30 units of product A if they produce 12 units of product B. Clear, students?
Yes, sir.
Okay. So that is about question number
24.
24. So here we have another question, question number 25. If we solve question number 25, what's question number 25?
Nutrition planning. A dietitian is considering 3 food types to be served at a meal. She is particularly concerned with the amount of one vitamin provided at this meal. 1 ounce of food 1 provides 8 milligrams of the vitamin. An ounce of food 2 provides 24 milligrams, and an ounce of food 3 provides 16 milligrams. The minimum daily requirement MDR for the vitamin is 120 milligrams.
Okay, then
If HJ equals the number of ounces of food type J served at the meal, determine the equation which ensures that the meal satisfies the MDR exactly.
okay, student, in this case there is a nutrition plan, and in nutrition plan there are 3 foods.
3 foods.
And these foods can be denoted by X. xj, which is given in the equation. So let x1 is food 1, x2 is food 2, x3 is
Food 3.
How many ounces of food 1? 1 ounce of food 1. How many calories it's going to be?
8 milligram
8
Milligram.
milligram. 1 ounce of food
provides
1 provides 8 milligram of vitamins. Okay, food 2 provides
24.
1 ounce of food 2 provides 24 milligram vitamins, and food 3 provides 16 milligram vitamins of milligrams vitamin. So let x1 is food 1, x2 is food 2, x3 is food 3. And what is the minimum daily requirement of vitamins? Which is given 120.
Yes.
So we start our question. It's question number 25.
yes
Let x1 is food 1, x1 is
Food
food 1, and x2 is
food
food
2
2, and x3 is
food 3
food 3. And minimum daily requirement is
120
MDR is 120 milligram. Is it?
yes sir
Yes.
So we have the coefficients, or we have the values of 1 ounce of food 1, that is 8 milligram vitamins. So that is a nutrition plan which contains 3 types of foods: x1 plus x2 plus x3. Clear?
yes sir
So x1 plus x2 plus
x3
x3 is equal to minimum daily requirement is
120.
What will be the coefficient of x1?
8
8 milligram. So x2 is
24
24, x3 is
16.
16. In part A, we have to determine the linear equation. In part A, we have to simply determine the linear equation. Is it?
yes
Yes,
sir
sir.
So what is part B?
if only one of the 3 food types is to be included in the meal, how much would have to be served in each of the 3 possible cases to satisfy the MDR?
So there are 3 types of food. Here they are putting a condition. If they include only one type of food in a meal, then how many minimum number of ounces of each food can be utilized to meet the minimum daily requirement? In this case, if they consider only food 1, if she consider only food 1, obviously x2 and x3 will be equal to 0. If she consider only food 2, then food 1 and food 3 will be equal to 0. If she consider x3 means food 3 in her meal, then x2 and x1 will be equal to
0.
0. Then we can simplify. What is question? In each case, how many number of units can be used to meet 120, that is minimum daily requirement. So part B, for x1 or food 1,
yes
Yes.
then x2
x3
and x3 are equal to
0
0.
0. Concept clear?
yes sir
Yes, sir.
So 8x1 plus 24 into
0.
0 plus 16 into 0 is equal to 120. So 8x1 is equal to 120. So x1 is equal to
15.
15 units.
Yes.
What does it mean? If she includes only food 1, then she must have 20 units of food 1 to meet its minimum daily requirement. Okay?
Yes.
Next is for
food 2
food 2. What is food 2? Means x2.
yes
Yes.
Then x1 and
x3
x3 are equal to
0.
0. Okay, students?
yes
So we can place the values here. 8 into 0 plus 24
x2
x2 plus 16 into
0.
0 is equal to
120.
120. So it's 0.
Yes.
Here is 0.
Yes.
24 x2 is equal to
120.
120. So x2 is equal to
5.
5.
Yes.
120 divided by 24 is equal to 5. What's the interpretation? If she includes only
Sec-
food 2, in her meal, then she must have 5 units to meet her minimum daily requirement. So, third case is for
Food 3.
food 3. For food 3. So, x3 we need to find.
Yes.
Then x1 and
X2.
x2 are equal to
0.
0. x1 and x2 are equal to
0.
0. 8 into 0 plus 24 into
0.
0 plus 16x3
Yes.
is equal to
120.
120. It's 0?
Yes.
Here is 0.
Yes.
16x3 is equal to 120. So x3 is equal to
7.5.
7.5 units of food 3 are required to meet her minimum daily requirement. Concept clear?
Yes.
Yes, sir.
So question number 2 is also related to real life. Question number 24 is also related to real life problem. Question number 26, we can solve question number 26 as well. What is question number 26?
Emergency airlift. The Red Cross wants to airlift supplies into a South American country which has experienced an earthquake. 4 types of supplies, each of which would be shipped in containers, are being considered. One container of a particular item weighs 120, 300, 250 and 500 pounds respectively. For the 4 times, if the airplane to be used has a weight capacity of 60,000 pounds and xj equals the number of containers shipped of item j, determine the equation which ensures that the plane will be loaded to its weight capacity.
Okay. There is an earthquake situation in some region of America. So they have to ship some supply. That is an emergency. And how many types of supplies are there? There are 4 types of supplies. And what is total capacity? That is 60,000 cubic.
Just
what's
pounds.
the unit?
Pounds.
Pounds. Okay. It's the case of weight. There is an emergency situation and they have to ship 4 types of supplies into that region. And the plane has capacity of 60,000 pounds. Okay, let x1 is supply 1, supply type 1, x2 is supply type 2, x3 is supply type 3 and x4 is supply type 4. So we start, let x1 is
Supply type 1.
supply type
1.
the supply item आप कह सकते हैं supply type 1, x2 is
Supply 2.
supply type 2, x3 is
Supply type 3.
okay and x4 is
Supply type 4.
supply type 4. And total capacity is
60,000 pounds.
total 60,000 pounds. Okay, 60,000 pounds. And here the number of containers are each supply types are given. If you read the question, one container's particular items weights 120,
20.
300, 250, 500 pounds respectively. What does it mean respectively? The value of container 1 means x1 will be the first value, x2 second value, x3 third value and fourth value is related to x4 respectively. Okay, so what will be the coefficient of x1?
120.
120. X2 coefficient is 300 and x3 is 250 and x4 is 500. In part A we have to simply determine the equation, determine the linear function. So 120 x1,
Yes, yes.
then
300 x
300 x2, then
250
250
x3
x3, then
500
500
x4.
x4. Total capacity is
60,000.
60,000. Concept clear?
Yes, sir.
Yes, sir.
We have simply convert the scenario into mathematical equation, into mathematical language. You should be very careful what is given, which information is given, and what we have to determine and what we have to calculate. So what is part B?
If it is decided to devote this plane to one supply item only, how many containers could be shipped for each item?
Okay, there is a condition that if they want to ship only one type of item, The rest of 3 will be
0.
0. For x1 means supply type 1. Then x2, x3 will be equal to 0. Then how many number of containers of each item or each supply type can be shipped? Okay. For x1, then x2,
x3
x3
and x4
and x4 are equal to
0.
0. We can simplify 120 x1 plus 300 into 0 plus 250 into
0.
0 plus 500 into 0 is equal to
60,000.
60,000 is equal to 60,000. It will be equal to 0?
Yes.
0, 0. So 120 x1 is equal to 60,000. Can we simplify here? X1 is equal to 60,000 divided by 120.
500.
So it will be equal to 500 containers. How we can interpret? If they devote
Only one.
only one or supply one, then they can ship 500 containers of supply one to the earthquake's place. Okay. What is X2 for?
x2
X2. Then X1, X3 and
x4
X4 are equal to
0.
0. So in this case 120 into 0 plus 300
x2
x2 plus 250
into 0
into 0 plus 500 into
0
0 is equal to 60,000. So it's 300 x2 is equal to 60,000. What's the answer?
200.
So x2 is equal to
200.
200 containers. Number of containers of supply 2 will be 200 if they leave the rest of the supply types. What is part? Next part for
x3
x3 for
x3
x3, then x1, x2 and x4 are equal to
0.
0. Okay students?
Yes.
So 120 into 0 plus 300 into 0 plus 250 x3 plus 500
into 0
into 0 is equal to
60,000
60,000. So 0, 0, 250 x3
Yes.
is it?
yes sir
Is equal to 60,000. What sum?
240.
240 number of
X3.
containers. X3 is equal to
240.
240 containers. Here we can find x4.
Yes.
For x4, then x1, x2 and x3 are equal to 0. So 120 x1 is equal to 0. Then 300
into 0
then 250
50 into 0
into 0 plus 500 x4 is equal to 60,000 is equal to 60,000. So we can simplify 500 x1 is equal to 60. Sorry, x4 is equal to 60,000. What's value of x4?
120.
120 number of containers can be shipped if they leave the rest of the supply types. So question number 27 is same, but there is a volume capacity. Here we are talking about the number of containers are in weight. In question number 27, the number of containers are in volume. The unit is in volume. You can solve it yourself. Okay?
yes sir
So here we can solve question number 28. What is question number 28?
personnel hiring. A software consulting firm has received a large contract to develop a new airline reservation system for a major airline. In order to fulfill the contract, new hiring of programmer analyst, senior programmer analyst and software engineer will be required. Each programmer analyst position will cost $40,000 in salary and benefits. Each senior programmer analyst position will cost $50,000 and each software engineer position cost $60,000. The airline has budget $1.2 million per year. For the new hiring, if Xj equals the number of persons hired for job category J, where J is equal to 1 corresponds to programmer, analyst, etc. Determine the equation which ensures that total new hires will exactly consume the budget.
This its personal hiring case. There is, I think, they are going to update their software system, and company is, I think, going to introduce their new software system. So they are required some employees, and there are 3 types of employees which are given in the question. One is programmer analyst, second one is senior programmer analyst, and third is software engineers. So everyone is having their cost, everyone is having their pay. So their salary, programmer analyst salary is, I think, 40,000.
Yes, sir.
Then senior programmer analyst has 50,000 salary, and the 60,000 will be the salary of software engineer, and the total budget is $1.2 million. So how many number of employees they are required to have?
3.
There are 3 types of employees they are required to have. Let X1 is programmer analyst, X2 is senior programmer analyst, and X3 is software engineers, and X3 is software engineers. So and we also know their coefficients. We also know their coefficients which are given. So programmer analyst costs 40,000. Senior programmer analyst costs 50,000, and the software engineer costs 60,000. So let X1 is
Programmer.
question number 28.
Yes, sir.
Let X1 is
Programmer.
Programmer analyst.
Yes.
X2 is
Senior programmer.
programmer analyst. X3 is
Software engineer.
software engineers. And total budget is $1.2 million. Total budget is 1.2 million. If we convert it into 0, so what can be value? 1, it's 1,200,000, is it?
Yes.
Okay, it's $1.2 million. So X1 coefficient will be 40,000. So in part A we have to determine the linear function. In part A we have to determine the linear function. So what's the value? 40,000 is the pay of programmer analyst. So the coefficient of X1 will be 40,000. Then the coefficient of X2 will be 50,000. This information is given in the question. Clear, students?
Yes, sir.
Then 60,000 X3 is equal to 1.2 million. 1.2
million.
In this case, we have to simply draw the function, determine the function based on given values or given scenario. What is part B?
If it were desired to spend the entire budget on one type of position, how many persons of each type could be hired?
Okay, if they desire to utilize all budget at one time of this hiring, for example, if they leave X2 and X3 means senior programmer and software engineers, and they want to hire only programmer analyst, how many number of programmer analysts can be hired by utilizing $1.2 million? For X1, then X2 and X3 will be equal to 0. So we can simplify for X1, then X2 and X3 are equal to 0. X3 are equal to 0. So 40,000 X1 plus 50,000 into 0 plus 60,000 into 0 is equal to 1.2 million. 1.2 million. Is it?
Yes.
So 50,000 into 0 is 0.
60.
It's 0.
Yes.
So 40,000 x1 is equal to 1.2 million. 1.2 million. So x1 is equal to 1.2 million divided by
40,000.
40,000. What sum?
30.
30. So see, programmer analyst, 30 programmer analyst can be
X1.
x1. So 30 programmer analyst can be hired by using 1.2 million budget. If they leave,
Yes.
if they are not required senior programmer analyst and software engineers. Okay.
Yes, sir.
Next is for
X2.
x2, then x1 and
X3.
x3 are equal to
0.
0. So 40,000
Into 0.
into 0 plus 50,000 into
X2.
x2 plus 60,000
Into 0.
into 0 is equal to 1.2 million. Okay, students? So 50,000 x2 is equal to 1.2 million. 1.2 million. So x2 is equal to
24.
24 number of senior software engineers can be hired. So for x3, then
X1 and X2 is
x1 and x2 are equal to
0.
0. So 40,000 into
0.
0 plus 50,000 into
0.
0 plus 60,000 into
X3.
x3 is equal to 1.2 million. 1.2 million. So 60,000 x3 is equal to 1.2
Million.
million. 1.2 million. Clear, students?
Yes, yes.
What's value for x3? So x3 is equal to
20.
20 number of software engineers can be hired. That is about, I think, part B, and we have also part C. What is part C?
If exactly 10 programmer analysts are needed for the contract, what is the
Okay, if exactly 10 programmer analysts, if x is equal to
10.
so x1 is equal to
10.
10, then
What is the maximum number of senior programmer analysts?
okay,
could
what
be
is the number of senior programmer
Program.
analysts? Then
maximum number of software engineers?
so here the question is divided into two parts. Number of programmer analysts, that is fixed, that they are required only 10. Then how many number of maximum senior programmer analysts can be hired? In this case, a software engineer is not given. But in next case, we have to determine the software engineers, but senior programmer analyst will not be there. So x1, if x1 is equal to 10, then x2 we have to find, and x3 will be equal to 0. This is case for software, senior programmer analyst. So what is the equation? 40,000 x1 plus 50,000
X2.
x2 plus 60,000
X3.
x3 is equal to
1.2.
1.2 million. 1.2 million. Clear, students?
Yes, yes.
The value of x1 is fixed.
Yes, sir.
But in this case, we have to determine the value of x2, which are senior programmer analysts. So 40,000 into 10 plus 50,000 x2 plus 60,000 into,
X3.
in this case,
Zero.
we are not talking about software engineer. That will be equal to
0.
0. That will be equal to
0.
0. So 1.2 million. So here is 400,000
Yes, sir.
plus 50,000
X2.
x2
Plus 0.
is equal to 1.2
2.
million. So first equation shifts the variable, one side constant,
Other side.
other side. So 50,000 X2 is equal to 1.2 million minus 400,000. So 50,000. X2 is equal to 800,000. Sorry here. Then X2 is equal to
16.
16. What is the pair? 10, 16 and
0.
0. What's the interpretation? If number of programmer analysts are 10, then they can hire 16, maximum 16 senior programmer analyst and software, none of the software engineers. Correct?
Yes, sir.
Here we have second part, maximum software engineers. Maximum software
Engineers.
if X1 is
10.
10 and maximum, sorry, X2 is equal to
0.
here the case is maximum software.
Engineers.
So here we have to determine X3,
Yes, sir.
then X2 will be equal to
0.
0. Is it
Yes.
clear?
Yes, sir.
So equation is given 40,000 into 10
Yes, sir.
plus the value of X2 is
0.
0. The value of X2 is 0. 50,000 into 0 plus 60,000. Is it?
X3.
X3 is equal to 1.2
Million.
1.2 million. Okay, students?
Yes, sir.
So it's 400,000. It's 0. We can simplify. We can directly solve here. So 60,000. X3 is equal to
800.
1.2 million minus 400,000. So 60,000 X3 is equal to 800,000. So X3 is equal to
13.33.
800,000 divided by 60,000, 13 point?
33.
13.23.
Yes.
1333. Number of software engineers can be hired. So what is the pair? 10,
0.
0 and 13.33.
13.33.
That's about question number 28. Question number 29 is same. Question number 30 is also same. We can discuss question number 30, I think. Yes, what is question number 30?
Political campaign. A candidate for the position of governor of a Midwestern state has an advertising budget of $1.5 million.
Total budget is $1.5
$1 million.
million for a political campaign. And what are the sources of campaign? Yes, next please.
The candidate's advisors have identified 4 advertising options: newspaper advertisement, radio commercials, television commercials, and billboard advertisement. The cost for these media options average $1,500, $2,500, $10,000, and $7,500 respectively. If Xj equals the number of units purchased of media option J, write an equation which requires total advertising expenditure of $1.5 million.
Okay, the total budget is 1.5 million dollar. And there are 4 types of, they identified, there are 4 types of campaigns. Like, I think which types are given? They have 4 types of campaigns like newspaper advertisement, radio commercial, television commercials and billboards. What is total budget? 1.5 million. 4 types of, there are 4 sources of instruments of campaign. I think newspaper, advertisement, radio, commercial and television commercial as well as billboards. So, let X1 is newspaper advertisement. X2 is radio commercials. X3 is television. X4 is billboards. Clear?
Yes, sir.
So, and there is also expense of each source of campaign. So what is cost of one advertisement which is which is done with newspaper campaign or newspaper advertisement cost
15
him or her $1,500. Then $2,500, 10,000 for television news, television advertisement, and 7,500 is for billboards. So X1 is newspaper advertisement. So we can write here question number 30.
Yes.
That X1 is
Newspaper advertisement.
newspaper advertisement. Okay, I'm abbreviating here. You can write in full. So X2 is
Radio
commercial. X3 is
television
commercial, and X4 is
billboard advertisement.
Okay?
Yes, sir.
Billboards. So total budget is
1.5 million.
total budget is 1.5 million. So X1 cost newspaper advertisement cost him
$1,500.
$1,500 X1
Yes, sir.
plus
2,500.
the radio per advertisement cost is
2,500.
2,500 X2 plus
10,000.
10,000 for television,
Yes, sir.
X3 plus 750 for
Yes.
7,500 for billboards, X4 1.5 million is
Total budget.
total budget. In part A we have to determine the equation. Part A we have to determine the equation. What is part B?
If it has been determined that 100 newspaper ads, 300 radio ads and 50 billboards will be used, how many television ads can they purchase?
Okay, here we have the value of three of these sources. That X1 is means newspaper advertisement is X1 is
100.
X2 is
300.
and X3 we have to find.
Yes, sir.
Means television we have to find. What's the value of X4?
50.
50 advertisements through billboards.
Yes, sir.
We can place these values in this equation and simplify the value of television or X3. So 1,500 into 100 plus 2,500 into 300
Yes, sir.
plus 10,000 into X3, because we have to determine the value of X3, plus 7,500 into 50 is equal to 1.5 million. Is equal to 1.5 million. We can simplify. Here the answer is
1,50,000.
here is
1,50,000.
okay. You need to tell me. Here what's value?
75
7,5.
4 mistake.
Okay, shoot it. What's next?
10,000.
10,000 x3. So 7,500 into 50.
3,75,000.
3,75,000 is equal to 1.5 million. We can simplify. So 10,000 into x3, shift variable one side, constant other side. So 1.5 million. 1.5 million
minus
minus
12,75,000.
12 lakh
75,000.
12 lakh 25
75
75,000. Okay, 1.275 million. So what's left? 10,000 into x3. What's this sum here?
2,25,000.
2,25,000. So x3 is 2,25,000 divided by
22.5
10,000. So x3 is 22.5.
5
Advertisement from television can be there if they have the television number of televisions. Advertisement from newspaper. 100 advertisement from newspaper. 300 from radio commercial and 50 from billboards. Then they can have 22.5 number of advertisement from television. Clear, students?
Yes, sir.
In this case, part C, billboards is fixed, that is 50.
Yes, sir.
In first, we have to determine maximum of x1. Maximum of x1 means newspaper advertisement.
Yes, sir.
Then x2 and x3 will be equal to 0.
Yes, sir.
Then maximum of radio
Radio
ads.
broadcast.
Then what will be 0?
X1.
X1 and x3 will be 0.
Zero.
Because the value of x4 is fixed.
Fixed.
Because the value of x4 is fixed. After that, for maximum of television news, x1 and x2 will be equal to 0. So part C is if x4 is
50.
50, then maximum, here we simply write for x1, then x2 and x3 are equal to
0.
0. Then you can solve by yourself. Next case can be there for
X2.
x2, then
X1 and X3.
x1 and x3 are equal to
0.
0. x4 value is fixed. Okay? And last part for
X3.
x3 means television news.
Television.
Then
X1.
x1 and x2 are equal to
0.
0. But the value of x4 will be equal to
50.
And these values, one by one, we can place these values in this equation.
Yes, sir.
Part A equation, and you can simplify each case. That is about exercise number 1.1. Here we discuss the how we can determine the linear equation, and I think question number 1 to question number 18 are just we have to differentiate either cases linear or not. And question number 19 to 30, they are very practical question. I will suggest to all students you have to make a good practice by yourself and try to understand the questions. They are real life nature issues, and first you have to extract what is given and what we have to determine. I wish you best of luck and see you in next class. Thank you.